Hey everybody, this coil of wire is very similar to the coil of wire we saw in the last video, but it's much smaller. We're going to run current through it and use this compass to determine the direction and strength of the magnetic field. The direction of the magnetic field is easy. It's just going to be the direction that the red arrow points in. But the strength of the magnetic field is a little bit more subtle. We can't measure it really from a compass. The way the compass behaves will be able to give us information about the strength. All right, here's our loop of wire. Notice what happens if I bring the compass close to it. As I move the compass around the loop of wire, the direction that the compass is pointing changes to indicate the direction of the magnetic field. How can we tell the strength of the magnetic field? Well, notice that it takes a long time for the compass to settle down. It tends to wiggle back and forth a lot. This indicates that the magnetic field is not very strong. But what happens if we take the compass and move it close to the source? It settles down really quick, indicating the magnetic field is much stronger closer. Now let's see what happens if we take this iron rod and insert it through the coil. First things first, let's see if it changes the direction of the magnetic field. Right now, the magnetic field here is pointing directly towards the loop of wire. Doesn't look to me like the direction changed. If we move over here, we see that it is again pointing in the same direction. However, there definitely is something different about the way the compass is behaving now. When we didn't have this piece of iron, the compass moved around a lot, indicating that the magnetic field was fairly weak. But look at what happens if we add the piece of iron back in. It appears that the addition of the iron is making the magnetic field much stronger. And it turns out this is indeed the case. Let's see if the iron itself is magnetic. The iron does appear to be fairly weakly magnetic. It turns out that iron is very responsive to magnetic fields. When we place this piece of iron in the electromagnet, the magnetic field from the electromagnet caused the iron to become magnetized. Then the magnetic field from the iron and the magnetic field from the electromagnet added together to make an even stronger magnetic field. As before, let's take a moment to think about what the direction of the magnetic field from this electromagnet is. Current is traveling this way along the wire and is looping in this direction. So what will the direction of the magnetic field be? Well, remember that if we point our thumb in the direction that the current is traveling, our fingers will curl in the direction of the magnetic field. As with the very large loop of wire, the magnetic field from this loop points through the loop itself. This was consistent with what we saw when we were using the compass to measure it. On one side, the compass indicated that the magnetic field was pointing this way through the loop. And then on the other side, the compass indicated that the magnetic field was pointing out. Around on these sides, we saw that the magnetic field was pointing this way or this way. This is consistent with the same behavior that we saw with the large loop. The magnetic field points through the center and then loops around on the outside.